All right, this is Precalc Chapter 2.6. We're going to talk about inequalities today, but not just lines. We're not talking about linear inequalities. We're going to be talking about nonlinear inequalities. But remember, just to kind of go back to what an inequality is that if I happen to have something like x is greater than 3, when we had just a line. Now, we could graph this in 2D, or we could use number lines. So if I had a line, or say a number line, then we could say, hey, we have a point at 3, it's an open circle, and 4, when we check it, is bigger than 3, so we would shade to the right. That's how we would handle it on a number line. If we were talking about a graph, like a 2D graph, XY plane, you would go 1, 2, 3, and you would put a dotted line because it's a vertical line, x equals 3, and then you would shade to the right because all of those values have x values greater than 3. So we're going to do the same thing here. It's going to be 2D, it's going to be on a graph, but what we're really going to be focusing on is the domain, or the x values that make it true. So these have ability to have graphs, so you'll have to shade inside, outside of parabolas, or left side, right side. But what it comes down to, again, is I'm looking for the x values that would make it true, the domain that allows it to be working. So when we say solve an inequality, and I'm going to have some examples on the next page here, we're looking for an interval, which are the x's. To start this off, we'll talk about the polynomial inequality. Polynomial inequalities, guys, are inequalities that have polynomials. So this one has many parts to it. We're going to start off with basically a higher order degree. So probably not lines, because it says nonlinear. You're going to have quadratics, cubics, and those things are going to be greater than or equal to 0. Or less than or equal to 0, or they're going to be greater than or equal to or greater than another polynomial. So to solve polynomial equations, these things are not too bad if we take them step by step. Now, to take them step by step, I would like you guys to, number one, I want you to bring everything to one side of the inequality. So your inequalities are going to have some kind of polynomial greater than or equal to, less than or equal to, some number or another polynomial. Bring everything to one side. Basically, set it equal to 0 is what we're trying to do. It just has an inequality sign. Because in step number 2, as you can see, I am going to set it equal to 0. That's bring everything to one side. And then we're going to solve the polynomial. Now, when I say solve the polynomial, as in step 2, when we say set equal to 0, I'm changing the inequality. So you may have something like x is greater than, or x squared, we'll even change it, x squared minus 4, and it could be greater than 0. I'm going to change it to x squared minus 4 equals 0. Because we've solved these before. We've solved polynomials. Our whole entire last lesson, or last basically chapter, has been solving polynomials. This can include factoring. It can include completing the square quadratic formula, and it also can go as far as using a synthetic division. So be very careful. So what we're doing is we are going to set it equal to 0, so treat it like an equation so we can solve it. I want you then, once you solve it, as our example here, it would be, x minus 2x plus 2 equals 0. I can say x equals 2, x equals negative 2. I've solved it. I got two answers. But this is an inequality. Inequalities are not our answers. They are going to be what we're going to call kind of like points of interest. These are our interval starts and stops. So what I want you to do in step 4 is to actually plot those on a number line. And when you plot those on a number line, what we're going to do, as we do here, negative 2 and 2, now I can go back and say, okay, I need to check my regular intervals on step 5, but you're also going to go back to the original problem. The original problem said it had to be greater than or equal to. 0. So it means where's the function positive? And the fact that since it says greater than, I cannot actually be at -2 and 2. So those will be open circles. Those open circles, guys, means that I can be up to -2 and 2, but I can't be there. Step number 5 says start to check numbers in the intervals. I've got 3 intervals. I've got an interval on the left, interval in the middle, and interval on the right. I'm going to purposefully pick 3 points. 0 in the middle would be a very good point. -3 would be an easy one, and 3 would be an easy one on the far right. So now, when I check my numbers, I want to say which one of those make the inequality true. So check the numbers in each inequality between the zeros of the original inequality to see which ones are true. So when I check them, I'm looking for the sign. Which ones are positive, which ones are negative. So if I put -3 into our problem, -3 squared is 9, 9 minus 4 is 5. That's positive. I go to the middle, 0. Well, 0 squared minus 4 is -4. That's a negative. And then I put in 3. 3 squared is 9, 9 minus 4 is 5. It's positive. And then in step 4 or 6 here, state the intervals and which make it true. That means this interval here on the far left is true. It's greater than 0. So I can shade that way. I can shade this way because, again, that is also making the inequality originally true. Notice that the middle is not true, so I cannot include that. So I got to state the interval now. The interval, and I'm running out of room here, about right above, we would say -infinity, open parentheses, comma, -2, open parentheses. We also have an interval with an open set of parentheses to positive infinity. That's a bad infinity sign. And because I have to use both, I would find that I am marrying or union of those two sets. That is how you would solve an polynomial inequality. Now, granted, there's going to be another mix-up on this in a second, but that's what you have to do first. So, the first example I got you guys to do is I want you guys to pause the video, and I would like you guys to attempt this. Remember your rules. Bring everything to one side, set it equal to 0, and solve it like any other normal polynomial, but use those zeros as kind of interval checkpoints so you can check points between them to find out which values you are making true, which ones you are not, and then state your interval. Okay, so first step, subtract 20 from both sides. That'd be the easiest way to make this happen. So x squared plus 5x minus 14 is equal to 0. I'm already changing it to equal 0. Actually, if we want, let's even back that up, and I'm going to say it's less than 0. So that way I can at least see my sign, my inequality symbol. Now remember, anytime I multiply or divide by a negative to both sides, I have to change and flip that sign. So be very careful, it's going to happen. So now I'm going to change it, make it a little bit easier for myself. And now I'm going to solve. So hopefully, are there factors of 14 that can give you a 5? 2 and 7. So let's check it out. X, 2, 5, 2, 7. And I have to have a positive 5, so that would be positive 7, minus 2, because they have to multiply to a negative 14. Awesome. So x equals 2, x equals negative 7. And now I can graph them on a number line. Now be careful your order. Negative 7's over here, 2's over here. The original problem was less than. So I'm going to have open dots. And that means that this polynomial here, when I plug a value in, has to be negative. I'm looking for really the negative sides. But I can choose a value like 0 in the middle. We like using 0 when we can. 3 is on the far right, and negative 8 will be on the left. You have options. Now I know that if I put negative 8 in here, I have to square it and then multiply it by 5 to add it and then subtract 14. It seems like a little bit of work. I've got a factored form as well. I'm going to use this form because maybe I only have to multiply numbers twice. Might be a little bit easier. Like, what's negative 8 minus 2? It's negative 10. So I might write that. Negative 10, okay? And then I go back up here, and what's negative 8 plus 7? That's negative 1. And if I multiply those together, I end up with 10. It's a positive. Awesome. 0. 0 is easy. Now 0, if I have a choice, I am going to put it into the original problem. Because 0 squared is 0, 5 times 0 is 0, so 0 plus 0 is 0, minus 14 is negative 14. So it's negative. And 3, I'm going to go again to the bottom. 3 minus 2 is 1. And 3 plus 7 is 10, which equals 10. It's positive. The problem's asking us, where is it less than 0? And the only interval that says it's less than 0 is from negative 7 is less than x, which is less than 2. And you have resolved. So this is our next problem. It's already been brought to one side. We're looking for where is this thing greater than or equal to 0. So I wonder, where is this graph positive? Now this one kind of pulls together some of the stuff that we did in our last section. So it's really kind of interesting. So the goal on this one would be definitely look for your zeros. To find your zeros, you need to make a list. Use upper and lower bounds. Potentially look for how many positive answers, how many negative answers, and then start using your synthetic division. Now, you can't see this, but I've already got this graphed on my calculator. I already know what the zeros are because I'm being that good guesser. That's what I told you guys to do. Take your calculators out and do this. And so I can see that there are 2 zeros and one of them is used twice. So I'm going to go straight to that. I'm going to skip over now, finding a list just to kind of save us time, but you guys really should be making that list. And no placeholders are needed. I just need to verify. I can look at this and say negative 3 is one of those zeros, but I'm going to verify. So then I get my numbers. Negative 3 times 2 is negative 6. Add that is 1. This becomes negative 3, which ends up being negative 15. And negative 15 times negative 3 is 45, which is 0. And now I get myself down to this quadratic. That's the nice part, is the fact that I already know that this is a 0. So a 2x squared plus x minus 15 equals 0. Now I could do this, or because I'm looking at my calculator, I actually know that negative 3 itself is used twice. And so if I really wanted to be that guy, I could just, hey, erase it out, do it again. Put negative 3 in there. 2, negative 6, negative 5, 15, 0. Because that means 2x minus 5 equals 0, or 2x equals 5, or x equals 5 halves. I now got 1, 2, 3 zeros. The degree is 3. I got them all. Okay, so not a big deal. Now, all I have to do is make those marks. But wait a minute. What we're saying is that I got negative 3 used twice, and I've got 2.5 there. Now, that's fine. It just means that I've got a double 0, which means if this is a cubic that is positive, the graph should look like this. Which means at this part right there should line up right here. It's touching, it's bouncing at negative 3. And guess what? It says that it's equal to this time. So that means there's a dot there and there's a dot there. They're included. And I'm going to test my points. 0 is nice, and 3 would be a nice number, and then negative 4. Now I have to put these values in. Now to save time, I've already got this on my calculator. I'm hitting second calculate, going to value, and I am physically putting in -4, and the -4 gives me a -13. I'm also going to put 0 in. It's -45. And I'm going over here and putting 3 in, and 3 is 36. Now that's interesting, because I'm looking for, what is the graph greater than? 0. Well, it's not greater than 0 over here. It's not greater than 0 over here, but it's greater than 0 over here. So we know this is happening. So we can obviously say that 5/2 with a closed bracket to infinity open is definitely there. But then wait a minute, we also have to say -3 is its own bracket. It touches at -3, which is 0, and take the union of that. So that is our answer. It's -3 and the interval from 2.5 onward. The next thing that's going to be kicking it up just a little bit is the fact that what happens if I have a rational function? Well, the rational function really isn't that much different, except for you need to write it as a single fraction. So if they are separated, put them together, which means get the common denominator. And then this time, you just need to include the zeros of the numerator, top, and the denominator on that line, that sign line, that interval stuff. So it really comes down to, it's the exact same thing. So the biggest thing, factor, 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 factor. But when I do this problem, I have to subtract 1 from both sides, creating x plus 6 over 4x minus 3 minus 1 is greater than or equal to 0. That means I need to have a common denominator, and the common denominator between this problem is 4x minus 3. So 4x minus 3 to the top, 4x minus 3 to the bottom, right? So I get x plus 6 over 4x minus 3 minus 4x minus 3 over 4x minus 3. Now the reason I wrote it like this is because that negative is very important, because I need to distribute that negative before I can combine them, and that is greater than or equal to 0. So I get x plus 6 all over, and then minus 4x plus 3, and that is over 4x minus 3, greater than or equal to 0. Gathering up like terms, x minus 4, x is negative 3x, and plus 9 all over 4x minus 3 is greater than or equal to 0. And now all you have to do is factor the top, factor the bottom, set them equal to 0. Those are your landmarks, those are your critical points. And so, negative 3x plus 9 equals 0, or negative 3x equals negative 9, x equals 3, and the bottom, x equals 3/4. Make my number line. 3/4. 3. They happen to be closed because I can be equal to 0. And now I just test it just like before. And so if I test 0, 0 is way over here. I'll end up with a negative number, because 9 divided by negative 3. If I put a number in like 1, 1 makes it negative 3 plus 9, which is 6 over 1, which is positive. And if I put a number in like 4, way over here, I get negative 12 plus 9, which is a negative 3 over 12, which is a negative number. I'm looking for where it's positive. It's only positive in the middle. And so we find that we should have an interval of not negative 3/4, but 3/4 is less than or equal to x, which is less than or equal to 3. And we found our answer. Homework is on page 145, 5, 6, 23, and 24. Make sure to come to class with questions. Have a great day.